Right, so good morning, everyone. Today we're going to cover the routing table. We're going to have a bit more detailed look at the routing table, try to understand how the routing table is built. So looking at this diagram in front of us, this is just like a topology. It could be anything. It's just a reference topology having a look at. Now look at R1 here. R1 connects to the internet. So what do you think, Muhammad? R1, R2, and R3 will have a default route. Which one do you think will have the default route to the internet? R1, R2, or R3? What about R2 and R3?
R2 will be static route. Will be connected by the through static route in order to connect to the internet. That will be configured in the R1.
Right. What about if you have a dynamic routing protocol? Dynamic routing protocol running on R1, R2, and R3,
Yes.
and they're exchanging routing updates. Do we still need to create static routes on R2 and R3?
No.
So how will R2 and R3 be able to reach the internet?
They'll connect to R1. That's why we use routing table.
But how do they know that R1 is connected to the internet? How do they know that?
Because R1 says that I'm connected to this IP. But
Okay, good. Using what kind of route and what do we need to do for R2 to tell the others?
we send updates like the ARP table.
No.
No,
R1, R2, and R3 running a dynamic routing protocol. Let's say, for example, RIP. So far, we've only learned about RIP version 2. We have other routing protocols, EIGRP in the next chapter. OSPF will take it as part of the link state routing protocols. But when you configure a routing protocol, such as RIP, on your network topology, then routers will send updates to each other about all of their directly connected networks, directly connected. However, if you create a default route on R1, which points R1 to the internet. So when R1 says, I have some users connected to me, to my fast Ethernet gigabit interface, and they want to reach the internet. R1 says, hey, I can take you there because I have a default route. Remember default route?
Yeah.
How do you create a default route? What is so special about default route? Do you remember the command to create a default route? IP route
IP, the address, I think.
0.0, yeah.
Put the subnet mask, which is 000.
Also all zeros.
And use the port on
Either
the port or the IP.
well done. Either the exit interface, or use the next hop IP address. Brilliant. So R1's problem is solved. It's happy. It's quite happy. It says, I can take my people to the internet. But if we just do this, create a default route by itself on R1, only R1 will be able to take its own users to the internet. What about poor R2 and R3? Someone needs to tell them, if you need to go to the internet, go to R1. Okay, and this is where we need to tell R1 to redistribute or share its default route to the internet with everyone else, and make use of the dynamic routing protocol, such as RIP or OSPF or IGRP, to tell the others, to advertise this to the others. Okay, and this is something I hope that we'll get to either today in the lab when you come, because you haven't finished the lab. When you finish the lab, or next week if you don't finish the lab today. So we create a default route on R1, then we use the dynamic routing protocol to advertise this to the others and say, hey guys, if you ever need to go to the internet, I have a path to the internet. I have a route to the internet. Come to me. I will help you to get your packets forwarded to the internet. So let's have a look. So we have, what else do we have here? Let's see. R1 is connected to network 172.16.1.0 through its G00 interface. R1 also has on the other side, on its serial interface, on the WAN link between R1 and R2, connects to 209.165.200.224. And then R2 also connects to 172.16.20/24. R3 has another subnet of 172.16.3.0. Can you see a pattern there? Can you see some kind of commonality between the LAN connected to R1, the LAN connected to R2, and the LAN connected to R3? Can you please explain more? What do you mean within the same IP address range?
Not that part. I mean like the three
and there is another one here which connects. Actually, R3 has two subnets.
Yeah.
Okay.
Like it's 1, 2, 3, and 4.
1, 2, 3, 4. They are what? They are subnets of what? Which network?
That's created through the routers, which is R1, R2, R3.
They are subnets. They are subnets of the major network. Same major network. What's the major network here? R1 is a router, not a network. No, they are subnets of the same major network. What is your understanding of the word major network? If I said, okay, if I said the same classful major network, does that make it any? No, classful major network. I didn't say classful routing protocol. I said classful major network. Look at 172. This first octet 172. If you are dealing with classful network, it's class B. Well done. So what is the standard prefix? The classful prefix for class B? From 1 up to 127 is a slash. It's a /8. From 128 to 191 /16, which is a class B. From 192 to 223 is class C. Okay, which is the prefix is what? 24. Then class D is the multicast addresses from 224 up to 239. So 172 falls in the range between 128 and 191. Falls in that range. Means if we were looking at this from a classful point of view, classful means we look at the first octet and decide what is the subnet mask, then the default subnet mask should be /16. So how come we have now in this position? Let's have a look at the 24. Yeah, and the last one here is 28. The second network is 28. How come we are using different prefixes here? Well done. We are using a classless routing protocol, which is RIP version 2. If this was RIP version 1 or IGRP, as we discussed previously, they cannot deal with classless, with VLSM. First of all, they don't support VLSM, classful routing protocols, no support with VLSM. And we said VLSM is another word that says we subnet a subnet. So we started with 172.16.0.0 /16. Then we divided it into 3 networks. The first network, the first subnetwork was 172.16.1.0 /24. /24 meaning the first 24 bits belong to the network. The prefix tells us how many bits. Meaning the last octet, the last 8 bits, the whole IP address is 32 bits, 32 minus 24, that leaves 8. 8 bits belong to the host. That means this particular subnet can have up to 2 to the power 8 minus 2, 254 hosts. So this particular, if you're looking at this network here, this can have 254 hosts. Now, the same thing, we created another subnet. Create another subnet, which is 172.16.2.0. This is a subnet of the same classful address 172.16 /24. Now, imagine where did 24 come from? Because originally it was 16. That means we borrowed 8 bits from the host portion. The host was 16 bits. The network 16 /16 means the network is 16. That left 16 bits for the host. From those 16 bits, we borrowed 8. We said, hey, we're going to now add you to the network bits. So those the third octet, which is the .1, .2, .3, this third octet, now became part of the network address or the subnet address, and which left only 8 bits for the host. Now from this 8 bits that we borrowed, we can create how many subnets? When we borrow 8 bits, how many subnetworks we can create? 2 to the power 8. So we can create actually 256 networks from this one major network, class B major network. We can create a further 256 sub networks starting from 0. We haven't used 0. I could have said 172.16.0.0/24. The 0 is the 0th subnet. This is also a valid network. The next one is .1, next one is .3 until we reach 255. So from 0 to 255 is 256 networks. Now we've taken the 4.0 network, and we did not use it here. The 172.16.4.0/24, we didn't use it here in our example. But what we did, we subnetted this subnet again. We borrowed another 4 bits from the remaining 8 bits of the host and added it to the network. So our prefix now became 24 plus 4 became 28/28. Meaning what? Meaning we can create a further 2 to the power 4, because we borrowed 4 more bits, 2 to the power 4, 16 more networks inside the 4.0. The 4.0 itself is a subnet. Now we've divided the 4.0 subnet into another 16 subnets. And this is the whole idea behind VLSM. You subnet a subnet. You subnet a subnet. You divide a subnet into smaller networks, further smaller networks, which meant that now for this particular network connected to R3, there is only 4 bits left for the host. So how many hosts we have potentially? Who can tell me? If I have 4 bits left for the host, how many PCs, how many interfaces I can configure with IP addresses? What is the formula? 2 to the power minus 2, because we cannot use the broadcast address, we cannot use the network address. So 2 to the power 4 minus 2, 2 to the 4 is 16, minus 2, 14 addresses. 14 addresses. Now, notice all of these networks, they belong to the same, they have the same subnet mask. If I did not use this 209 address for R1 and R2, and did not use also between R2 and R3, and I kept the same, I use one of the other /24 networks here. I just said 4.0/24. For this one link, I said 5.0/24. For this one link, 6.0/24. If I kept the same major class, which is all of them, they start with 172.16. So this is the same major network. All of them have the same subnet mask. Then this is called a contiguous network. Contiguous يعني all يعني منسجمين انسجام. They all belong to the same parent network, the same classful major network. They all belong. They all have the same prefix. This is a condition to be called contiguous. You have the same major network and you have the same prefix. And all of your subnets in your organization, in your topology, they follow this rule. With this kind of scenario, IGRP and RIP version 1 will work happily. They are classful routing protocol, but they are able to work with a subnet mask such as /24 for a class B address. They can take it with this condition, has to be met. All of them have to have the same subnet mask. The minute you start changing the subnet mask of one of them from /24 to /28, /27, you have a problem. Why? Because they don't send the subnet mask information, the class for routing protocol. They don't tell each other, hey, this network has a class, has a subnet mask of /24 or /27. It is up to the receiving. So when R1 sends an update, let's say this was RIP version 1, not RIP version 2. One sends an update 172.16, 1.0/24, it doesn't send it as /24. It just says, I am connected to a network 172.16.1.0. Now, assume now, just for the sake of argument, assume that this 209 is not 209. It is also 172.16.5.0/24. So when R3 receives it, it says, hold it, you did not send me the subnet mask because you're classful, aren't you? You are RIP version 1, you're classful. So I need to guess. Let me check. This interface I have as 000, this interface, which network does it belong to? It says, oh, it also belongs to 172.16 major network. The same major network that you have sent me, I also, my interface where it entered this update has the same major network. Therefore, guess what? I'm gonna apply the same subnet mask for my serial 00 to your update. It's gonna make an assumption. Now, in the case where all of them have the same subnet mask, this assumption actually will be true and it will work. It will work. But what if this assumption is wrong? What if, for example, look at R3 here. R3, when it sends an update to R2, the network actually is /28, not /24. When R3 receives it, let's say also this network here between R2 and R3 is another subnet 172.16.6.0/24 also. So the only one which is different is this far right network connected to R3. When it sends an update to R3, it says, I am connected to a network. This is the version 1, 172.16.4.0. Doesn't say /28. This is classful. So R3 says, oh, my serial 00 interface belongs also to a network which has a major network, also 172.16, matching your major network. Therefore, I'm going to apply my own subnet mask to you. So for this particular network, the 172.16.4.0, what will it apply? It will apply /24. Will it be correct? No. It made an assumption, and this time it failed. So it will have an incorrect entry in its routing table. It made an assumption that has the same. This is why we said, remember, we said RIP version 1 and IGRP, they are classful routing protocol. They do not support VLSM, and they do not support classless interdomain routing. What does it mean, don't support classless interdomain routing? Meaning that they do not send the subnet mask information with the update. This is what it means, classless interdomain routing. You send the subnet mask. If you don't support classless, you don't send the subnet mask. The second point, they don't support VLSM. You cannot have different subnet masks of the same major network in the same topology. You cannot have it. So RIP version 1 and IGRP will work happily if all of them have the same major network, condition number 1. So 172.16, this is major network. 172.17, this is a different major network, not the same. So all of them 172.16, all of them 172.17, or all of them 10.000, or all of them 192.168.1. So all of them have the same major network. As this is condition 1. Condition 2, all of them have the same subnet mask. Okay, now let's have a look at this example. This example, we don't have the same major network between R1 and between R2, between these two, this one here, this network here, between this network here. Separating R1 and R2 is a completely different major network. It's actually a class C, which is 209.165.200/30. So the network is actually 200.224/30. This network is completely different, major network from 172.16. Because we have broken the rule of having, remember the condition 1, all of them have the same major network. When you break this rule, we create something called discontiguous networks. ما كن سجام بعد. كانوا قبل before they were contiguous. Contiguous, انسجام. Now they are discontiguous. So يعني ما متفق، يعني مو نفس النتورك، غير نتورك، غير major network. So now one R1 has this IP address, this network, it wants to advertise to R2. How can it advertise it? It has to go from here, from a serial 00 to reach R2 the update. Correct?
Yeah.
This is what, let's say it is still what? This is RIP version 1.
Yeah.
This is, now I'm trying to show you now that RIP version 1 cannot work with this contiguous. It fails. So when R1 wants to send this update 170.16.1.0/24 through its serial 00 interface, it will realize the IP address for the serial 00 interface belongs to a different major network. So it creates mentally a boundary. It creates a boundary between the two networks. Let me just. So this is R1. This is my 172.16.1.0/24 network. And this is here is S000. And this is 209.165.200.224, yeah, /30. Because of this difference here between this major network, the major network here is what? This is my major network.
209.165.
And the major network is here 170.16. Because of the difference, I have now what is known as discontiguous boundary.
So it doesn't react to it.
This is discontiguous. So what does it mean, discontiguous now? How this will make it behave? So remember, RIP version 1 only sends what? Sends only the network address without any subnet mask information. Before, when this was also, let's say, 172.16. let's say 5.0/24, it had the same major network. It actually sent 172.16.1.0 sent it. Because when those match, when the major network match, it will send the full subnet information still without any subnet mask information, but the full subnet. Whatever is this IP address, it will send it. But now, when we have a different major network and we cause a discontiguous situation, it will send now what? It will send only the classful, the summarized classful network. So it will send 172.16.0.0 only without any subnet mask information. So when R2 receives it now, when R2 receives it, it will receive only this. It will receive only this. So it will check its own interface IP address. It says my interface IP address is completely different. It belongs to this major network. And I've just received 172.16.0.0. What is the subnet mask? It says, since nobody told me what the subnet mask, I will assume it is the classful subnet mask. So in R2's routing table, there will be an entry, let's say RIP, R for RIP, it says 172.16.0.0/16, because /16 is the classful subnet mask for a class B type network. Now what happened here?
It's different.
It's different. It's not the correct one, because our real subnet mask is 24. Now R2 has what? Has a /16, and this problem can cause unintentional load balancing. Unintentional load balancing, and we will talk about this later. Unintentional load balancing between the networks, and it caused some of our packets to be lost. Now this is a problem for RIP version 1. RIP version 2 is classless. But remember the no auto summary. Remember? No auto summary. So for EIGRP and RIP version 2, we need to remind them not to summarize by default. Now, if I change the situation now to RIP version 2 is going to send, even if this IP address, network address connecting R1 and R2, it has a different major network from the network I'm advertising. Because it is classless, it will send the correct update. It will send 1610 with the prefix /24. Assuming what though? Condition number 3 is what? No auto summary was done. If I did not do no auto summary, rev version 2 will behave just like rev version 1. It will automatically summarize, and it will send the prefix with it as a /16. Rev version 1 did not send any prefix information. Rev version 2, because it is classless, it will send. But what will it send? It will not send the /24. It will send the classful subnet mask /16. Why? Because we forgot to put the no auto summary. No auto summary disables summarization by default, or automatic summarization. So if you want the real subnet mask to be sent to your neighbor for rev version 2 and EIGRP, you need to include the command no auto summary, disable automatic summarization. When you do this, then it will actually send the correct network address with the correct prefix. Any questions here? Okay. Right, let's see. What do we have here? This is basically, if we did show IP route on R1, you notice we have a static route on R1 we created, which is our default route to the internet. This is our default route to the internet. Now, this default route to the internet will be redistributed or advertised to both R2 and R3 using the command default information originate. So when you put the command router rep, when you did this in the lab, router rep, under router rep, you put default information originate. This command will look for your default route. If you have configured a default route, such as IP route 000 with an exit interface or a next hop, it will look for this particular type of route, and it will use RIP as a transport to tell all of the others. So RIP will take this one and advertise this to R2 and R3. So this is the contents. Notice that R1 has learned 1, 2, 3, 4, 5 RIP routes. And they have all the correct prefix. Why? Because two things we did. One, we have run rev version 2. 2, we have used the no auto summary command. No auto summary. If we did not use the auto summary command, I will have only one entry in here, which is 172.16.0.0/16. Yeah? So 1, 2, 3, 4, 5. Is this correct? Let's have a look. Is this correct? So from R1, it has learned this network. This is 1. This is 2. This is 3. This is 4. And this is 5. This is 5. 1, 2, 3, 4, 5. What about this network? This network from R1's perspective, is it remote or is it directly connected? Okay, so the 209.200.224, notice the 224 entry, where is it? Here, this one here, this line. This one is with a C next to it, is directly connected. Whereas the 228 has been learned via RIP. The 228, which is this one here. This is the 228. So anything which is not directly connected to R1, anything which is not directly connected to R1 is considered what? Remote.
So what's this 192.168.0.0?
This is another network. It's like, let's assume this is like R4, but we don't show R4. So you can see this is like a WAN link or connecting to this network, okay? But still, it is 192.168.0.0/16. This will be learned by R1 through RIP version 2. For R3, it is directly connected. But for R1, it is remote. So let's look in the routing table. Do we have 192.168.0.0? 192.168, there it is, 192.168.00/16. It has learned via rep. We can tell it is via rep from two things. One, the R is a giveaway. It tells us it was rep, R for rep. The other thing is the administrative distance. 120, which is for rep. 110 OSPF, 100 IGRP, 90 IGRP. So we can tell. What about the two? The two here means it's 2 hops away. So to reach this network, I need to go through 2 routers. Is that right? Let's have a look. From R1's point of view, how many jumps does it need to go? This is R1. To reach this, I need to go, this is 1 hop. R1 to R2, this is 1 jump. This is the second jump, the second hop. Then I can reach this network. Okay? So in general, this is what a routing entry will look in the routing table. It will always have the root source. How did we learn this route? From what? Is it R for rep? Is it O for OSPF? Is it D for EIGRP? Is it C directly connected? Yeah. The actual network address itself, the destination network, the admin distance followed by a slash and then the metric. For rep, the metric is, we said it's hop count, the number of hops, via the next hop IP address, my neighbor's IP address. How long ago did I learn it? This was 12 seconds ago. And in order to reach this neighbor, this next hop, I need to send my packet out of my own serial 000. So this is my outgoing interface, my own outgoing interface. This will take me to this neighbor IP address. Okay, so let's identify parts on an IP version. Let's have a look at this IP version forwarding table, then we answer these questions. This 10.4.0.0/16, what is the root source for it? For the 10.4.0.16. Let me ask Rashid. Let's ask Rashid. Can you show me? Okay, what is the S? Static. So what do we choose?
Routing source,
Static. What's the admin distance?
admin distance, no.
The admin distance is not mentioned, but for static routes, it's 1. The default for all static routes, the admin distance is 1. What is the metric?
0. 1 or 2?
I'm not going to say anything. What do you think the metric is? You said 1?
No,
cannot be 1.
0, sir.
It is 0. The metric. It's not directly connected. The static, there is no, the metric is 0. Exactly. Right. Let's go for the second one. Okay. Muhammad, you take the second one. 172.16.2.0. What is the root source?
Directly connected, so it's static.
So it is direct, so it is connected. Connected. Okay, this is
static.
172.16.
Oh, yeah.
172.16.2.0, yeah? 2.0 we're looking at.
Directly connected.
Yeah, it is a C. So C, it is connected directly. So you put the word connected. Okay, what about the admin distance?
There is no admin. It's directly connected, so there is only one. Only on one admin distance.
Which one is considered closer? One we reach via static route or directly connected? Directly connected. If the static route is 1, the admin distance, what is better than 1? 0. What is the metric? Also 0. What about 3.0, Abdullah? What is the source? What is the letter next to it? What is D? What did you say D is? Which protocol is D? It's EIGRP. Okay, thank you, Rashid. Yeah. What about the admin distance? Let Abdullah please answer. What is the admin distance for 172.16.3.0 network? What's the admin distance for EIGRP? What's the yeah? Can you read it? Exactly. Yeah, that's one. Okay, 90. What about the metric for this route? What is the metric for this route? Yeah? Yeah? Well done. What about, okay, go on, Rashid. 192.168, 110.24, which is this one. This one. What is the root source? OSPF. Good. What is the admin distance? Admin distance. 110, thank you. And then the metric is 65. Okay. Muhammad, 192, 168, 120.0, which is this one. What is the root source? Rep.
The admin distance is 120.
Ayman, this is 120. Well done.
And the metric is 1.
And the metric is 1. Correct. That's 1 here. It's 1 hop count. Okay. Is this reversion 1 or reversion 2?
This is version 2. No, 1.
1? Okay. How do you know it's 1?
Because it's class C, so it starts from 192 and to 230. So class 4. It's because of the subnet, that's how I know the prefix.
This router, it's a bit of a trick question. This router here has directly connected network 172.16.1.0, 2.0, yeah, and 192.168.1.0. So it has 3 networks which are directly connected to it. The remaining ones, it was learned by GRP, OSPF, and RIP. Those 3 directly connected networks, do they all belong to the same major network?
No.
But still, we have the correct subnet mask information. Meaning what? Sorry? It's reversion 2. Because if it was reversion 1, it will have looked at them as discontiguous networks. It could not have dealt with it. It would have summarized this 172.16.0.0, it has summarized it all to 16. Yeah? No, it is, sorry, I beg your pardon. It will have, because it's directly connected, but it would have summarized, let's see. No, actually, it is this one, the static route. What else? No. Actually, no, it's difficult. It's a bit of a trick question, not unfair question, because difficult to tell from this routing table alone here. Because all of these networks at land, actually they have their class 4 subnet mask. These are all class C, class 4 subnet mask. So it could have been actually either. Just looking at this routing table is not enough. But most likely it is reversion 2, since we have a mixture of different type of major networks. Okay, most likely it will be reversion 2. Right. Right, so now we need to learn some terminologies, but it's going to have to be after the break.
Summer break?
Sorry?
Summer break?